reflecting functions. Okay, this graph given here is just a random function, and the points listed in the table, we're going to call the original points. And we're going to look at some examples of how ordered pairs change when we do different types of reflections. Okay, on example number 1, it says graph negative f of x, the reflection of f of x across the x-axis. Okay, so what is another name for f of x? What's another name that we call f of x? Y. So to help us remember what they're really saying, if negative f of x can also be written as negative y.
Is that note 17?
Mm-hmm.
And do we draw the original one? Or do we write that?
Where's that at?
Okay, so what we're going to do is we're going to take every y value and make it negative. Okay, if it tells us negative f of x, that really means negative y. Okay, so instead of positive 7, it's going to become negative 7, right? Instead of positive 1, it's going to become negative 1. Instead of positive 4, it's going to become negative 4. Instead of negative 3, positive 3. Instead of negative 3, positive 3. Okay? So I'm going to take all of those values and I'm going to graph them over here. Negative 7, negative 1, negative 4, positive 3. All the x's are going to stay the same. Okay, so I'm going to graph those over here. Negative 6, negative 7, negative 4, negative 1, negative 1, negative 4, positive 4, positive 3, and then positive 8, positive 3. The original graph that we started with was this one. Okay, all these original points, and we're going to look at several different reflections. The first one is negative f of x. In other words, take the entire function and make it opposite. Okay, since f of x means y, then negative f of x means negative y. So that's how we took the original points and we made them all opposite from what they were. Okay, and if you look at the original graph compared to the new graph, okay, all it is flip every point that was above the x-axis below, and everything that was below, we flipped it up. Okay, so to help us remember how to do a negative f of x, okay, that just means we're going to change the y values. Okay, we're going to change the y values. Okay, on example 2, notice that the negative is inside parentheses. So every x value is going to be different. So when you reflect across the y-axis, you're changing every x value. Okay, the original x's were negative 6, negative 4, negative 1, positive 4, and positive 8. Now we're going to make all of those the opposite. So positive 6, positive 4, positive 1, negative 4, and negative 8. Okay, all of my y values are going to stay the same. Okay, so 7, 1, 4, negative 3, negative 3. Okay, whenever I graph those, the original graph will be reflected across the y-axis. Okay, so positive 6, positive 7, positive 4, positive 1. I'm graphing the new points. The original is where I got the new points. I changed all of the x. values to the opposite. Okay, so positive 1, positive 4, negative 4, negative 3, and negative 8, negative 3. Okay, so if you compare the original graph, how that looked, okay, then you would expect it to be reflected across the y-axis, okay, side to side. So in other words, every point in this original graph that was on the left is now going to be on the right, and every point that was on the right is now going to be on the left when you reflect it that way. Does that make sense? In example 3, graph the reflection of the function f of x across the origin. Okay, the origin is at 0, 0. Okay, and to reflect across the origin, we're going to change x and we're going to change y. Okay, we're going to change both of those. All right, if we change all of the x's, those are going to become positive 6, positive 4, positive 1, negative 4, negative 8. Okay, and then all the y values are going to change as well. Negative 7, negative 1, negative 4, positive 3, positive 3. So you just change both. When you reflect across the origin, it's a combination of both, changing across x and changing across y. Okay, so graph those points. 6, negative 7. 4, negative 1. 1, negative 4. Okay, negative 4, positive 3. And then negative 8, positive 3. Okay, on the last example, graph the reflection of the function f of x across the line y equals x. Okay, on this one here, all we're going to do is switch. Okay, we're going to switch x and y. So instead of negative 6, positive 7, it's going to be positive 7, negative 6. Okay, the next one will be 1, negative 4. 4, negative 1, negative 3, 4, and negative 3, 8. Okay, I have the line y equals x graphed here. That is your parent function. Okay, I'm going to graph the new points. Seven, negative 6, 1, negative 4, 4, negative 1, negative 3, 4, and negative 3, 8. So you can kind of see the original graph kind of turned, didn't it? It made a turn when you reflected across the line y equals x. So just to let you know, the original point, for example, negative 6, positive 7 was right here. And whenever I switched those, positive 7, negative 6 was over here. If I connect those, that line would be perpendicular to the line I reflected it over. Does that make sense?
Yeah, is this what we're doing?
Mm-hmm. So reflections take a perpendicular direction. Okay, if you want to just eyeball it when you're trying to guess on a problem about where the point is supposed to be, is supposed to be perpendicular from where it started, okay, across that line.